Australian mathematics curriculum, solving equations. Here's an algebraic equation. We can tell it's an equation because it's got an equal sign and two sides, something on each side of the equal sign. So, to solve an equation, we need to find out what the unknown is. Now here we've said something plus 4 is 9. It's really obvious, it's 5. 5 plus 4 is 9. But we need to show that mathematically. X equals 5. We need to work out how we did that so we can do harder ones and show it mathematically. Here's another way of looking at it. There's something unknown in the box. We don't know what it is. But plus 4 of those things equals 9 of those things. An equation just has to be the same on both sides. So if I take away one thing, I can even erase it properly. If I take away one thing from both sides, it's still equal. As long as I do the same thing to both sides, it remains equal, it remains true, until I get to the point where I can't get rid of anything else from this side, and I'm just left with x plus nothing goes away, and I can see that the equation now tells me what x equals. X equals 5. So to solve an equation, we do the same thing to both sides to get x on its own, and when x is the only thing left on one side, the number on the other side must be what x equals. So when we do x plus 4 equals 9, we know that we want to get rid of the plus 4, and we do its opposite to both sides. Now some people set their working out by saying minus 4 on this side and minus 4 on that side and putting them in little circles to say we're just doing this. X plus 4 minus 4 cancels out. Sorry about noise in the background. And x equals 9 minus 4, which is 5. So for another example, x plus 4 equals 7. We want x on its own, so we've got to get rid of the plus 4. We're going to take away 4 from both sides. Another way we could show that, x plus 4, and after it we put minus 4, equals 7 minus 4. Always put the thing that we want to do to both sides after the other things. Plus 4 minus 4 cancels out. X is 7 minus 4. X equals 3. And we can substitute it back in to check. Is 3 plus 4 7? Yes, it is. We're right. An example here. X minus 3 equals 10. We want x on its own. We want to get rid of the minus 3. So I do plus 3 to both sides. Again, I can show it in little circles if I'm not feeling very mathsy. It cancels out on that side. X minus 3 plus 3 is just x. And on this side, I've got 10 plus 3, which is 13. Double check. 13 minus 3 is 10. Yes, that's correct. 3x equals 15. Now this means 3 times x equals 15. We need to do the opposite of timesing by 3, the opposite of multiplying by 3, which is divide by 3 on both sides. 3x divided by 3 equals 15 divided by 3. 3 over 3 cancels out, leaving me with x equals 15 divided by 3 is 5. Substitute it back in to check. 3 times 5 is 15. Yes, it is. And the last sort here, y divided by 2 equals 10. We want to do the opposite of dividing by 2. which is times by 2 on both sides. Y divided by 2 times 2 is 10 times 2. So I'm doing different sorts of working each time. This one's the better sort. Divided by 2 times 2 cancels out. So y equals 10 times 2, which is 20. Substituted into check, that's 20. 20 divided by 2 equals 10. We're correct. So those equations only had one step because they only had one number that we needed to move away from the unknown. There are such things as two-step equations. And in two-step equations, you need 2 steps to solve them. So for example, here, we've got 3x plus 2 equals 14. To solve two-step equations, we have to work in reverse order of operations. So plus and minus get dealt with first, then we deal with times and divide. Sorry about my little squiggly and sign. So the first thing to get rid of is the plus 2. To get rid of plus 2, we take away 2 from both sides. And let's not even show working this time. Let's just take away our 2. 3x on this side equals 14 minus 2 is 12. And now it's just a one-step equation. I need to get rid of times 3 on both sides, so I divide by 3, leaving me with x equals 12 divided by 3 is 4. And I can still substitute it back in. If x is 4, 3 times 4 is 12. 12 plus 2 is 14. We're correct. So a two-step equation just does the first step, and then it's a one-step equation, which is nice and easy. See how appropriate working can be done just showing each line? We don't even need to show in a two-step equation what we've done, but of course we still can. It's still okay to put a little minus 2 in circles on both sides to say, hey, I did minus 2 on both sides on this line, and then I did divide by 3 on both sides on this line. That's okay if you want to. There's all sorts of ways to show working, but these 3 lines for a two-step equation are just fine.